Good afternoon everybody, it's your friendly theorem prover. Today we're going to be proving theorem 2. The perpendicular bisector of a chord passes through the center of a circle. Off we go. We start with a circle with chord AB, and PT is the perpendicular bisector of AB. There's PT, perpendicular bisector of AB. We're required to prove that the center of the circle lies on PT. Proof by contradiction. Contradiction has the same meaning as in English, and we're going to make an assumption that we're going to work with. That seems reasonable. We're going to work with it, and when we get towards the end, we're going to realize that something's not adding up, and so our original assumption must have been incorrect. Hence the contradiction. Assume that the center of O does not lie on PT, and you will notice that the center O is drawn it like that. There's PT and O is not on it. We join OT together. Right, as a result, OT is perpendicular to AB. We've gone line from the center to the midpoint of a chord, and so OT must be perpendicular to AB via our theorem, line from center to midpoint of the chord. What we now have, of course, is that OTB, which is the angle we have just made, and PTB, which is what we started with, are both 90. Oh my word, but this is a contradiction. It's not possible if you look at OTB and PTB to both be 90. They are in the same place and they are different sizes. So clearly from our picture it looks like OTB is more than 90. We've just proved it is 90. So we have a contradiction, and it's only possible if O lies on PT. So my assumption is clearly incorrect, and the center of the circle does lie on the perpendicular bisector of AB. I have proved that by contradiction. Moving along, you try one for yourself now. There we have it, different labels. And what do we do first? You will notice we make a construction and exactly the same thing. Assume that the center O does not lie on PT and join OT, and it follows in the same way. Well, that's all for now, folks. See you again. Bye-bye.